Dynamic programming is a powerful tool in computer science widely used for solving optimization problems by breaking them down into smaller subproblems so that you don't have to recompute the same problem again. But then why NASA avoids dynamic programming in a spacecraft system? First and foremost reason is memory uses. Dynamic programming requires a lot of memory usage to store the result of subproblems, and NASA's onboard system use specialized processors like ID750. These processors are built to survive the harsh environment of the space like high energy radiation but come with limitations. For example, they usually offer only 128 MB to 256 MB of memory, a fraction of what your smartphone has. As dynamic programming relies on storing results of subproblems, what we call memorization or tabulation, while this saves execution time, it eats up memory, and in space memory is a luxury NASA can't afford. Next up is safety critical coding standards. NASA has a strict rule to ensure every line of code is predictable and safe. For instance, NASA avoids recursion because recursion can cause some stack overflow problems and unpredictable behavior in the system. NASA also avoids go-to statement to keep the code easy to debug and maintain, and uses fixed bounds for loops so that it ensures that program won't run into infinite loop. Dynamic programming with its reliance on flexible memory structure doesn't fit these rigid requirements. In NASA's onboard system, static memory allocation reigns supreme. Why? Because the size of every data object is fixed and known at compile time. This predictability ensures optimal use of limited hardware resources, especially in embedded systems like a spacecraft. Dynamic programming, however, introduces uncertainties. The size of its data structure changes at runtime, which make it harder to control memory usage precisely, something NASA can't risk in space. Now, don't get me wrong, NASA is not completely against dynamic programming. In fact, it's extensively used in ground-based systems. For instance, the Ground Data System Group used dynamic programming to optimize data transmission between spacecraft, rovers, satellites, and mission control. Their resources are not as constrained as in a spacecraft, so they can leverage dynamic programming for its efficiency. In summary, NASA avoids dynamic programming in space due to memory constraints, safety critical coding standard, and the need for the predictable system behavior. But on the ground, it's a different story. By understanding these trades-offs, we get a glimpse into how NASA keep our space mission running smoothly. So with this note, thanks for watching, and I will see you next time.